Welcome back. A long time ago, in a YouTube far away, I had made a video, actually 12 parts, PixInsight video for absolute beginners. And part 3 was Subframe Selector, as you can see right here. And that is 4 years ago. So it's time that we update that to the latest version. So let's get started. For those who are absolute beginners, you will find that process under Process, All Processes, Subframe Selector. I believe there's another way to do it. I believe it's Process Image Inspection, Subframe Selector. So let's go and we'll open it from here. All right. That's number one. Number two is you would think that Subframe Selector would be done after blink, right? So you blink them, you've removed all the traces of jet satellite, clouds, whatever it is, right? Because you can do that visually. There's some things you just cannot do visually, like how round are the stars. You can tell on some when they're really bad. Same with bumping when you're guiding, bad guiding. But anything deeper or more technical, that's where Subframe Selector would come in. So you blink, and then you would think that right after that it's Subframe Selector. But I had to do some research to do this update on this process, and apparently not. No, you can, and I've seen people do that. By far the majority are not doing this right after blink. What they do is this. They blink their subs, and then they calibrate them. And you end up with an extension or a prefix or postfix of C, _C. And then they cosmetically correct them, which is end up with a postfix CC. So now you have C _CC for cosmetic correction. And then you debayer them. And now you have a D, which is debayer, right? I'm just talking about one-shot coloring. I'm not talking about narrowband or mono. Now, before you go to R, CCCDR, which is registration, well, no. Why? Because you need your best frame, and the best frame is going to come from your Subframe Selector. To do it right and to get the right numbers and the right weights, you're going to want to be at that section of debayering, but before registration. And I'm going to show you why in a minute. I'm going to move this over here. And I'm going to move this over here. And when I add my files, when I load the files, you're going to get these fuchsia text. Noise estimates are not available in the image metadata and are being calculated from possibly non-raw or uncalibrated data. So what does that mean? It means that the image weights can be inaccurate. It's one thing to click a bunch of buttons and say, whoop-de-doo, here we go. But I want to tell you why. And I hope that you'll understand why. You don't have to do it. I'm just, if I'm going to make a video, at least I'll try to be accurate. And I'll try to keep it simple. And I'll try to explain it in a simple way. So without touching anything, let's go to add files. And I've got a whole bunch of files here in the last 3 weeks. I got maybe 200, 300, 400. Okay, let's open those. So they're in the list from 1 to 63. So far, so good. Okay, and we have it. The routine will be measure subframes. I heard that under subframe scale, which is your camera telescope scale, arc seconds per pixels, and camera gain, you can leave that all alone. Technically, if you leave all this alone, you're going to get a result here in the graph. But if you want more accurate results, I suggest that you find those two. And I'm going to show you. Let's work on this. So the formula to figure out what I put in subframe scale, arc seconds per pixel, is this. Pixel size divided by telescope focal length times 206.265. Okay, so in my case, I have the 533 ZWO or ASI. I have the RC6, which is TPO, 1370 millimeters at f9. And I'm using the Astrophysics 0.67 reducer. We now have the microns of each pixel. My focal length, because I've reduced it, is now 858 from 1370. And I'm going to multiply that by 206. Okay, so it's 3.75 divided by 858. Okay. Times, what does it say here? 206. 206.65. That should not yield 84. 90. Okay, so 0.90, and we ignore the rest. So I now know that 0.90 is what I need to enter for my image scale. So let's remove this. What is the gain? I went online to ZWO and I downloaded the chart for the 533 ASI, and I looked at gain, electrons per ADU, and that night I was not shooting at unity, because if I was shooting at unity I would enter 1.0, which is why I show 1.0, but that's not what I had. What I was shooting at is 202. So at 202 is just about here. It's more than 0.3 or 0.30, because this would be 0.50. If I move this over and I double click, just open one up, fits header, gain, it's 202. My offset was 40. We now that my pixel size is 3.76. But what we're searching for in the header, it's E gain, electrons per ADU. Remember what I said on the picture? I figured roughly 0.3, 0.30, and we can close this now. So it's 0.31. That's the information I want. This is the information I want. Okay, so we can close our fits header. Let's come here, and our electrons per ADU when I was shooting was 0.31, because we're going to output these later. So click on the little folder, come over here, go back to your 417 on November 26, and I have November 26 approved. And this is really important here. The keyword, even though it's by default SS weight, leave it SS weight. Next step up, we're going to toss this over and we're going to apply global. Let's see what happens. Now it's going to measure them. All right, now people see this. People that have contacted me says, you know what, I've seen this new Subframe Selector. I am completely lost. Lots of graphs and lots of bars and lots of numbers, and what do I do? In all these drop-down menus, there's going to be what you want to display. And primarily we're going to work with three things for my personal reasons. Full width half maximum is a very good one. Tells you whether your stars were out of focus, some clouds went by and the stars got bloated, bad tracking, anything that will affect your stars being tight and small. And there's no magic number, because if you're using a refractor, it could be as low as 1.9 to 2.2. And if you're using a C8, it could be from 3.8 to 6.4. And because the number is high, it doesn't make it bad. It's just that's what your telescope and your focal reducer and your camera and your pixel size gives you. So that's the first thing I look at. The second is eccentricity, and that is, are the stars elongated? And thirdly, stars. The more stars there are in your image, more than likely the darker, the sharper the focus. And eccentricity is going to affect how many stars you have. And then there's a whole bunch of things like guiding, again, haze, clouds, moon, everything. Wind will affect eccentricity, but primarily the background of the sky, if it's really good, the star count will be really high, or some people call it star density. Okay, let's go back to full width half maximum. Way to do that for the beginners is that you can do all this manually. I'll show you. You can do it manually. So here's what we need to think about and to look at. This black bar here, that's the median value of all the frames, because this black bar can vary depending on what you choose here in the measurement graph. So with the median value, you have like a two-tier system. You have the dark gray, which is +1, -1, and you have the light gray, which is +2, -2, and those are standard deviations. So you have one standard deviation from the median, and you have two standard deviations from median. And what we would like it to be is all these little blue lines to be inside at least the second standard deviation, which you can see I've got quite a bit, so that's a good thing. But what I don't have on full width half maximum is these guys here, these outliers. I've got one that's way up here, 4.5. I have 4.3. You're saying, well, where are you getting 4.3 from? Well, the little black box that shows up, it says index 46. Full width half maximum 4.3. There's weights, median, sigma. Another thing that I like is the index. If you notice here, I'm going to hover, index 46. So because up here I've chosen index, I'm going to scroll down to number 46 because it says index 46. 46 says a full width half maximum of 4.34. So this graph, the graph is a representation of the numbers in this list. Now I could have put them in order and changed the index to full width half maximum. If I do that and I scroll back over to full width, which is this list right here, and I start back at the top, the best ones will be at the top, 2.5, which is excellent. If we scroll down to file number 65, or whichever one it is we're up to way up to 4.58. So this is a good thing. Just by looking at what you've set here in the measurement table, a full width half maximum, you know that you have a really nice frame here at 2.5. And if I slide over, it ends up being frame number 14. Sorry, 0073. Ignore the brackets. Okay, so that's just an example of tracing this dot to this table. So before I do anything on the graph, you have to assign a weight to this. And if you look at this list, this is the very first box right beside file name on the right. Nothing. There's 0. But while this was running, it was doing some calculations, but it didn't apply them. Why? We didn't put a weighing number here. Well, actually, it's not a number. It's an expression. So the simplest one that I can think of, and we can do a more complicated one later, is SR, right? SNR, weight. Now, and make sure the spelling is absolutely correct, because it'll just reject it and you'll have an error down here at the process console. So SNR weight, let's hit the little execute and watch the weight list. And now we have weights. Let's move it over. We have 1.861 all the way down to 1.69. And they're not in order because I have it set on the table. I have it set to full width half maximum. If I went to weight, I have a weight of 168 in the top image and 2.06 at the bottom, which is much better based on its weight. Well, if you have clouds passing by and your image is brighter, do you know what's going to happen? PixInsight is going to think that that frame is brighter, so the signal to noise ratio is going to be higher, but that's false. That's a bad frame. You need to reject that. I don't want you guys to go by numbers. If the signal to noise ratio is really high, it doesn't necessarily make it a great frame. I would rather have more stars. Oh, by the way, if you have a high signal to noise ratio and your star count is low, that's a red flag. All right, so we have this, and under approval, I'm not going to do anything for now, because I want you guys to learn the first part manually. So that's a no-no, because it's 2 levels or 2 tiers standard deviation above the median, which is the black line. I don't want this one, and I don't want that one. And these two are really marginal, but we'll come to that in a minute. All right, so how do I know that these full width half maximum are in fact stars that are too big. Well, visually, it's kind of hard to tell, but we'll show something in a minute about that. These two, you can select them, but you're cutting out right off the bat 5 frames. All right, good. Next, we did full width half maximum. Eccentricity. A high eccentricity means a star that is absolutely not round. We'll show that in a minute. Okay, in eccentricity, you have more stars that are above the 2-tier of standard deviation, 2 steps over. So obviously this is in the white. I don't want that. And this is in the white, and I don't want that, and I don't want this, right? Let's prove this. Let's prove this right now. I'm going to move this down. Okay, and we're going to use the index again. So I'm going to hover over here, and according to index 25, which I suppose you could go up here and change the weight to eccentricity, move that back, go up to the top, which is the best one, and the bottom one should be the worst. And what does it say here? 25. Why is there red X? Because I made it red X. I chose to reject it manually. All right, so this is good. Move over. To have a look at index 25, because it sure would be nice if you could look at it, right? Don't double click in the red. Don't double click the lock. Double click the file, and it should show up. So let's stretch it. Let's have a look if file number, or the index 25, file number 0073, is really as horrible as the eccentricity graph shows. Let's zoom in. Now, what do we have? A bunch of eggs. Nice dodo bird eggs that are extinct. So that's good. That's very good. So look at the, they're pretty stretched. Would you want that in there? No. Okay, let's close it. But I chose a few other ones. Let's see if we can choose something a little bit lower, like for example 068. So that would be index number 7, which is right here. Okay, let's double click. All right, let's stretch it. This is going to be a long video. And let's zoom in. And what do we have? Elongated. I'm not sure what's going on here. It could be anything. A little bit of wind. Tracking, definitely tracking. On some. So that file is not really something I want to keep. Sometimes, like, I don't have a lot of frames, and last night was a clear night, and I only got 50 frames. I don't want to throw away 14 frames and end up with 36 or whatever. So look, I'm zoomed out. Can you tell? I can't. I mean, by looking at it this way, I can't tell that they're elongated. So it's personal. Don't stack them; they're bad. Or stack them. You're just starting out. And you want to be impressed, so you put in as many frames as you want. But if you want to be really strict, that's a goner. Now watch this. Now I'm going to go, because later on we're going to do automatically, we're going to use the approval. This is a representation of something. Let's go to, let's say, index 18. It just happens to be the 5th from the bottom. Let's do it. Let's double click that. We're going to stretch it by using the nuclear button. And I'm going to zoom in and see if it's nice and round. Well, they're not that round. In fact, that's oblong. Let's keep going. Those are not round. Those are not round. Those are definitely not round. So what just happened here? What happened is I took everything below the second standard deviation. But if I had to put in here, I want you to approve anything that's bad, like above 065, let's say. So we have 068, we have 070, we have 070.4. But if we come down here, we have 064. Well, we just double click that file and look at it's not. It's elongated. Now, to me, that's bad news. Why is that bad news? Well, I was depending that this graph, represented wise, would give me some good frames. And it does. It really does. Especially with the first tier standard deviation from the median. This dark section, either a plus or -1. These frames must be pretty good. Let's go to index number 23. 23 is right here. That's frame number 5 in my Nina list. By the way, it says that this full width half maximum of this file is 2.75 and it has 525 stars. Let's just double click that. Okay. And let's stretch it real quick. Let's zoom in. Yeah, it's pretty good. So I pick one in the middle. Now in the middle is not the best frame. Why? Because the best frames are the lowest. So what would be the lowest one? I believe it's 33. And I think if we scroll up, 33 should be pretty close to the top. Yes, in fact, it is just the third one. So double click. 038 from 070. Eccentricity wise, those are gorgeous. I wish I had 100 of those. But there we go. So technically, the software is doing its job, and we verify it by double clicking on the files that we feel they might be a little iffy. Okay, we've got 2 accomplished. We have full width half maximum right here. These are all bad. Oh, did you notice something? Before I had 5-ish files that were rejected, and now I have what, 8? Because what's nice is when you flip in the measurement graph from full width half maximum to eccentricity, it keeps the one that have been rejected. Because you might start thinking, hey, whoa, hold on a second. These are, what are they doing so low? I'm on full width half maximum, and the circle shows that it should be really, really sharp. Well, I'm sorry, full width half maximum, very tight. But no, because it kept the second measurement. So I found that interesting when I did my research. All right, so we have this one covered. We have this one covered. The last one that I like is my star count. The star count, to me, it's really, really important. I'm going to go up here and change the table to stars. I'm going to scroll to the top. So the worst one in this case, I have it upside down. I could change ascending to descending, but you know, we know what we are doing or what we're trying to accomplish. So frame number index 25 with frame number 74 shows 229 stars. Is that good? Is that bad? What if there was only 250 stars? That'd be fantastic, right? But I want you to look at the bottom, which shows 1,245 stars, which you would kind of assume that must be one of the good frames. And in reality, it's showing a full width half maximum by Nina, not by PixInsight, of 2.75 with 525 stars, not 1,245. Don't ask me why. I don't know how that calculation is made with the algorithm. This is a really, really good frame. Okay, so we have 1,245, and our worst frame says it has 229. Something during that part of the night, and by the way, this frame is 1:38 in the morning. So the star count is accurate. So from 200 to 1,245. So under stars, this one down here shows 229. It is in accord with 229, right? I don't know if I want that one in there. You could say, I could double click it and bring it up here, but I'm not going to be able to tell if it was cloudy. If the guiding was bad, yes, I could tell. If the eccentricity was really bad, I could probably tell. But just by saying it's a really, really low star count, you know, maybe it could be lighter. All right, so here's a reason for a star count that's low. It's a bad frame. Hey, but you know what? Is number 28, did it get mark off in eccentricity? Apparently not, because look, it's got a green check mark. So what happened here? I'm glad these things happen. Let's go find out, because you definitely don't want this. The thing is, if I missed it, if PixInsight missed it, if the algorithms missed it, this should not have been missed in blink. That frame should not even be there. All right, but let's say you missed it in blink accidentally. You know, you're distracted for a minute. So that's a bad frame. And if you note its number, it's 074. All right, let's close this for a second. Now I want to go back here and go to eccentricity. Maybe it's okay, and I just, you know, I'm not thinking straight. Eccentricity, number 74, right here. It shows green, and it's index 33. Let's go to index 33. The header's right here, 33. Showing eccentricity of 037. Well, if the numbers are low, especially on the second tier of below the median, -2. That should not be there. Okay, that should have been marked as bad. Even in the approval, which we're going to do later, the automatic approval, which are right here under eccentricity, that would not show up. So that was a failure on either my part for not looking properly, and the software, well, it's not the software's problem. It just said it looks fine. Actually, in a way, you could say the software didn't see that and should have marked it high. But we together proved that index 33, let's double click. Anyways, we know that somewhere in this pile there is a file, an image that is really bad. Okay, anyways, if I output all these and I reblink them, you can guarantee that guy's going to be there, and I don't want to do it right now. Now that we know it's index 28, not 33, let's go back to our graph. I'm going to close this now. No sense leaving that open. Almost dead center on the median. So this file here, which is this file here, which is the one that's really bad, okay, 229 stars. Remember that? Let's go back to stars for a moment. I don't have to, but that file is bad in terms of star population. This image, 074-1, it's going to get rejected anyways. The image was really bad, double bump, and I'll tell you what happened there. It accidentally did a meridian flip without my permission because everything was set to do not flip, right? There's no sense in flipping. I have a wall 5 feet from me. Why flip and look at the wall? But it did it without my permission. And the only reason I knew that is because when I looked at PhD, it says the guiding has stopped. Telescope is slew. And go, no, you're not. And I went outside, and it was. And like, oh man, I could have tore something apart. So always keep an eye on your gear. For those who fall asleep and wake up at 4 in the morning, hope everything's fine. Well, I hope everything's fine. So 229. The next is 479, which is index 57, which is about, there's 46, there's 57. Now, 479 stars compared to 1200 is quite low, right? Sure. And it's showing here below the standard deviation of -2. But let's open it up. Be careful with that because I just showed that not always. Let's stretch this. And this one, it just showed a lower star count, right? So lower star count. Well, look at this. These stars are not eccentric. If the stars are not round, you would stand to reason that the stars in the back, like let's say magnitude 15, 16, 17, they'll be stretched a lot and they'll become so faint that they're not going to show up in the star count. I'm done. In stars, I have everything below 600. It's been chosen, and we have some really nice ones here, 1245, which is great. So I better hurry up here. We'll never get this done. It's already been almost 45 minutes. Okay, so we seem to be happy with everything above and below, 2 standard deviations. So we're going to change this to output the subframes, all right? You just want to output them where? Well, the directory I pre-chose ahead of time, November 26th, approved. Okay, remember, SS wait in capital letters, no S. I'm just going to hit it. I'm going to move this over so we can see the console. Going to hit it, and then we're going to go check inside that folder. Let's go to IC417, November 26th, and these are the ones that we chose, approved. And you notice they have a _A. That _A, technically, it's supposed to be there, but it's in the wrong order. It should be C, CC, D for DeBear, A, and then from here, you're going to register them, right? You're going to register them? Yeah. So where's my best frame? Well, it's not here. These are all the best frames. They're all the best frames. They're all good frames. So even though we outputted them and we kind of have to output them, we need to go back to the subframe selector and find out, based on your criteria, how strict you want to be or how loose you want to be with your set of data. How are we going to choose our best frame? And this got complicated for me because I'm like, well, I'll choose the one with the more stars. And then I find out later that that one's full width half maximum is not that good. I mean, it's okay. It's on the median somewhere close, negative or positive 1 from the standard deviation, but that was not the one, right? So I'm like, well, what am I going to do now? So okay, I guess I'll pick the one with the best eccentricity. I found one, but now the star count's low, and I wanted to have it, 800, 900. So now you guys are probably scratching your heads, go, well, what's he going to do? Or what are you going to do here? The decision has to be made of what the best frame is. Okay, so remember we entered SNR weight, and it forced the weight on these frames based on the calculations that were going on in the background. All right, let's go back. Change this back to, oh, by the way, let me show you a little trick, which is kind of cool. Let's use full width half maximum. As you can tell, some of them, they're really, really high. They're kind of out of focus and out of round. And right beside it, if you want, you can put it along with star count or star density. Okay, here's what's cool. Is if this frame has a full width half maximum of 4.5, you also have a star count of 479, which is pretty low. Logically, that makes sense. I mean, if you have really big stars, then some of the smaller ones just got washed out. They didn't show up. So let's look at another one. Let's look at this one here. 1,245 stars. That's almost the max. I think it is the max because I'm on the bottom of the blue chart. Let's go to how many full width half maximum in this way because it's inverted. By the way, that's a little gray dotted line. I tend to play a lot between those two. When I mean those two, I mean between this chart and this chart, this graph and this graph. So we have 2.5 really tight stars. And because they're tight, we got 1,245 stars across the image. So they almost mirror each other. As you have a high star population of 1,000. Now, we could also say, I want to have the stars on my right. There they are, just the gray line. But I want the eccentricity in light gray. Left is blue, right is gray. All right. So everything in blue here are stars. So we have really low star count here. And we're looking also for low eccentricity. We don't want high eccentricity of, let's say, 0.52, right? Whatever it is, we want a lower number. So if we go to the dotted line, we have 0.36 in eccentricity. We have 751 stars. Okay, so this is the way you can use the chart. This is another way you can compare your stars to you could change that to full width half maximum if you wanted to. Again, they mirror each other. If you have a really low full width half maximum of 2.25, I would expect a lot of stars. And if I go up here, 1,245. Okay, so that's it. Really? Okay, we're done with all this, but we got a problem. I don't know which one of these 63, let me put this back on index. Index puts it 1 to 63. Which one of these files, images, shouldn't say file, is the best one of all? Are you going to choose stars? Are you going to choose full width half maximum, eccentricity, signal to noise ratio? Because in Nina, I can't do that. Oh, yes, I can. I'm going to do this. I'm going to get out of November 26, go to November 25, and 274. All right. With 274, we have 503 stars. Because Nina, in the naming convention, I said, look, when you're writing out this to the file, could you please put minus 15 degrees, gain at 202, offset at 40, we're binning 1 by 1, and the full width half maximum is 2.74 at 503 stars. Yes, it's 180 seconds. Is there something better in this whole list on that whole night that's way lower than 274? Yeah, and I went down the list 1 by 1 and I found 233 with 616 stars. And when I double click this and I put it in PixInsight, well, it is razor sharp. The stars are really, really, really round. They're really tight. There's a whole lot of them. So without even using PixInsight, Nina, and I've double checked this in PixInsight, already gave me the reference frame. Now this is not the folder from the 26th. That was from the 25th, but I want to show you something. All right. I guess you're all waiting to see what we're going to put in approval. But for that, we have to start all over. So this is like part 1 of part 1 and part 2. This is the best at 2.0. Let's open it up. 2.063. Double click. And this is supposed to be the best weighted file. All right, let's have a look. Let's zoom in. Okay. All right. So this frame, I was looking for eccentricity. I don't see any, so that's a good thing. And star count's around in the middle range, around 718. From 1200, it's a big drop. 500 stars are not there. Okay, well, you know, I'm flexible. Anything else? Well, no. Overall, I suppose if you wanted to, you could choose this as your main reference frame for registration. An AstroPixel processor. Cosmetically correction is done at the very beginning, and local normalization is done because it's built in. Okay. If I'm not going to use noise, as in signal to noise, or I'm not going to use weights, well, I'm going to have to use something else. And in one way, the graph, I'm just going to put that to full width half maximum. In one way, this graph down here, it kind of helps you a lot. If we put this back to full width half maximum, and we put this on stars, and now we have full weight on blue. We have stars on little ants, little gray ants. If we can find a really low full width half maximum, like 2.52, and we can find a really, really high star count of 1,245, to me, that's definitely my reference frame, right? All right, so this is 1, right? Now, in the list here, I would like to list them in that formula. So how can we do that? Well, I have it already set to full width half maximum. So let's go to the list, which is right here. All right. So they're showing from tightest to the largest. We can change that. We can go descending. And now we have 2.5. You know what we can do? We can grab this and put it right beside stars so they're partners. Full weight, stars. Full weight, stars. Full weight 2.5, 1100. Or 2.75. 2.74, 1100. 2.74, 1100. 2.7. Okay, these here files, until you get to about, what did I say was the best one I thought? Index 6 with 252. Right here, 252. All right. There are some that are even better. Apparently, well, I can see them. But the eccentricities are fairly high at 55, 60, 63. There's 53 right here, which is nice. 52 is nice. And 56 is nice. All right. Since we're on the topic of high star count and good full width half maximum, let's go look at index 4. Why? Because I want you to understand no guesswork here. So this is a really high count of 1185 frames. It's got a nice 2.7 full width half maximum. But guess what? These stars are not round enough. Okay, they're a little bit long. And the table here, okay, the table, it reflects that here, 060. Again, without even opening an image and looking at it, I could tell by the numbers. I'm going to stop this video in a minute because even though this is, let's bring it back up. Even though we're here, PixInsight Part 3 for Absolute Beginners Subframe Selector 2019 or whatever it was. And the one I'm doing right now, which is this one here, will be Part 3 update. Say, well, you're not finished. You didn't tell us what you're going to, what are you going to choose, Mitch, for a frame? Okay, here's what I'm going to do. I'm going to reopen Notepad for a second. And I'm going to have to make a little line here. Yeah, don't mind my notes. I'm going to make a line here because I want to write down. You'd say, well, are you going to write down your best frame? Nope. Then what are you going to do? Well, I'll show you. Okay, so here's what I'm going to do. Because this is the reference frame, I don't want the reference frame to be one frame or one image. Okay, I want the top 5 frames. equals. Now, get their names, get their numbers. Let's go back. Okay, low full weight, high stars, not too high of eccentricity. So I like this one here. Oops, I'm always going to lose my notepad. So I'm just going to kind of call them out. 073 is good. 53 just above it. So that way I'll see them and I'll know when I'm in the directory, I'll know that in brackets 5 and in brackets 10 is what I meant by //. Like if I could put them in bracket if I had to. What else do we have that's fairly nice? We have 055, that's 7326. 0073 / what is it? 26. How many do we have? 4? 3. Okay, so now what are we going to do? You got a whole bunch of reference frames? That makes no sense. You're right, it doesn't. I'll get to that in a minute. So are we done? Oh, well, we're done right now for everything we've done. Everything we outputted was great. We have absolutely no reference number. We have reference numbers, which is right here. Okay, so what are we going to do with this? Well, if you want to create a reference frame, why not make it a real good reference frame? I mean, based on multiple low frames for full width half maximum and a high star count. We used to call, I thought about this in 2018. Me and Stevers were talking about that. I said, why don't we make a super ultra reference frame? Instead of one frame, let's make the signal to noise ratio really, really high for signal and really, really low for noise. So here's how we do it. Now, remember these are the good ones. Now you're going to have to find your notepaddy thing, and in here, this is going to disappear again. I'm going to just go make a folder. Did it make one? No. Make a folder. Now it did. Master. Ref. LN. Well, LN if you ever use it for local normalization. All right. So now we have to track those guys down. Right click, cut, open, paste, 5 files. Why do I put them in a separate directory? Because I don't want to chase through all of them when I go to create a master reference frame. They're not aligned. So let's align them. Image alignment. Oh, don't want to do that either. Let's go to file. We're going to need one. Should have wrote my best one. Well, I kind of did wrote my best one. 73.5, which is right here. Add the rest. Oops. My bad. These are going to have to be cleared now. Okay. Output directory. You could put them the same if you want, but we're already master reference file. And I'm just going to put down a line. Do you really have to do this? No. I just want a master reference frame that's going to be a lot cleaner and a lot tighter for the other 500-600 files that I'm working on. We're good there. You can generate drizzle if you want. This is good. Postfix will be R. Don't bother with this. Don't bother with that. Don't bother with that. Let's create those 5 files. And let's just register them so they're all aligned. Because you can't stack them if they're not aligned. My bad. Okay, now move this out of the way. Let's go get them. Aligned. Okay, we didn't change anything. We're still going to do, well, I guess when I reset it, I changed everything. Average, additive, don't care. Percentile, and don't generate maps, and apply global. By now, if you were my viewers from 3-4 years ago, you're all experts. This is not absolute beginner stuff. It's not like I have to slow down and explain it all. You probably watched it 10 times. Okay, now we can move this over, and all went well. These guys are all lined up. And they make a beautiful file. Man, oh man, that's 5 frames. And look at the nebula that came out after 5 subs. 5 of the best subs. I'm starting to see the Spider Nebula. Okay, for the heck of it, again, this is going to be a long video. Let's go back to here, and notwithstanding those that I just did, let's have a look at how many files I've collected so far. So there's 12.4 gig, and there's 746 files in 19 folders. Okay, and I'm aiming for 40 hours. I'm aiming for 900 frames, but you guarantee I'll scrap 200. Okay, let's go back to this and just leave that up. Okay, so what do we do? Close that now. What are we going to do now? Well, we're going to take this file and return it. Don't lose it. It took me a while to catch on. I'm like, okay, if I have 14 nights and there's a ton of dithering and a ton of meridian flips, that's going to be a disaster to register, right? By now, you probably guys know the answer. But not if one, that cannot be a JPEG, XISF. One file, one master reference will be forced onto all 900 frames so that all 900 match this guy. Okay? So default. Okay. Okay. Thank you. You're welcome. I'm done. I am done. If you only have 50 frames and you're scrapping, I don't know, 14, it's not really good. Let me just, wait a second. I'm going to try something. Remeasure subframe. Let's say that these have all been, they've all been selected. You have little dots here and a little dot there and a little dot here, and you decided, well, okay, I'm going to, I can't aim. Okay, depending, this is on PSF, but just ignore that. And you decided, okay, I'm going to output them, right? And you're going to hit the button, and you're going to be SS wait. You're going to be in the right directory. Let's go there. Let's go and let's pretend we're at the end, because we are now at the end. And you did all this, right? Well, I hope I copied. Anyways, there's your 5 frames. Hopefully I copied them. It doesn't matter. What's my point? My point is this. If this is approved, I am going to delete that folder. It's too confusing for me, and I have a small brain. We have 66 minus 3. So we have 63 frames here, right? As we were in the original, I think we had 64 when we originally started. Here's the thing. I'm not going to call it a problem, but for me, it's really annoying. These are all the frames you started with, but they're all the good frames and the rejected ones. Like, can you tell me which one's rejected here? Okay, which one is it? Oh, I didn't write them down. Maybe I should have. Because in the old days, when you output here, you could say directory for approved, go here. How about directory for rejected? Go here. And then once I got here, all I had to do is go to 2 different directories for, this would be November 6th approved, and to be November 26th rejected. And this would kind of be empty because I would have not copied, but I would have cut and pasted. So you're stuck with all these, and I don't mean stuck, but if you have a big hard drive, like 5 terabytes, you can have 5 times the amount of files because these are accumulative on top of those. And if we did this, and we right click and check the properties on that, you're at 2 gig. When in reality, I don't care about that. I just want to know, oh, now what's going on? Just want to know if 99, so just under a gig. That covers the simplest, easiest way to do it. I'm going to shut the video off. It's been 1 hour and 15 minutes, I believe, and I'm going to do part 3C, and this one's going to be full of weights and expressions that I had to borrow from really smart people, and I'm going to try to explain what's going on and why. And it's going to do the same thing that we just did manually. Okay? I'm stopping the video now. Thank you for watching. Hope some of it was helpful, and I hope this video actually recorded, because if not, I don't want to start all this over again. It does happen. Thank you for watching.